Is it started? Oh, yeah. Okay. Perfect. Thank you. Okay. Welcome, everyone. So this is the first interim meeting, the OAUTH working group interim meeting. Just as a reminder, not well applies here. So if you're not familiar with this, please make sure you understand what that means. What we're going to talk about here is security BCP this week. So we still have 2 more meetings. Next week, we'll be talking about is logged in and web ID. So make sure to attend this meeting. And in November 30th, we will be talking about DPOP. So this is our schedule for the coming few weeks. Before we switch it to or give it to Daniel, I just want to talk about one topic. There was some flare of activities around or flare of discussions about OAuth 3.0. I just want to make sure that it is clear that currently the OAuth working group is not working on any new version of OAuth protocol, and we are working with Roman to kind of put an official statement to clarify the proper way of bringing any work to the OAuth work group and working on a new version of this protocol. So this is just a statement, just to make it clear what the status of any work on the OAuth 3.0 here is. We're not working on anything like this, and we will talk about a proper way of doing this. Okay, so that's all we have from a kind of a chair's perspective. I will hand it now to Daniel to talk us through. Stop sharing here. To talk about security BCP.
Thank you.
Okay.
Okay, let me find the right screen here. Okay, you should now see something?
Yes.
Excellent. Okay, welcome everybody here today. We want to talk about the OAuth 2 security best current practice document, which is a draft by Thorsten, John, Andre, and me. The document itself, as I guess most of you know, sets out to describe the best current security practice for OAuth 2. It updates and extends the OAuth 2 security threat model. We try to incorporate experience from practice as well as from research, and cover new threats that are relevant to OAuth 2. In particular, also those that arise in high-risk environments, for example, in open banking environments, or when OAuth is used to, in EID schemes or for electronic signatures or applications like that. This is a relatively old draft. I think it started in 2016 or something. We had the first working group last call end of last year. That was on version 13. We got a lot of feedback on that, very good feedback, but it also meant we had to do a lot of work still. Now we are at version 16, and I think that things are looking much better than they did last time. So let's go through the changes that we made since version 13. So what's new? One thing is that we noticed that you can do something which we called PXE downgrade attacks. Relatively simple. An attacker uses a stolen non-PXE bound code and injects it into a flow where PXE is actually used. If the authorization server can handle both non-PXE flows and PXE flows, then the authorization server might accept the non-PXE bound code, although in the current flow, the client thinks it's using PXE to protect itself. We have a more detailed description of the attack, of course, in the document. Our new recommendation regarding this attack is that authorization servers must ensure that if there was no code challenge in the authorization request, a request to the token endpoint that contains a code verifier must be rejected. So this is, as we heard, also something that implementations actually, or some implementations already do. So I suspect this is a relatively small change. Then we have some smaller changes regarding PXE and nonce and the recommendations around that. A new recommendation is that I think it's a very natural thing. PXE is now a must for public clients. We kind of missed to state this very clearly in the old versions. So PXE is a must for public clients, and there's no way around it. You can't use nonce in this case. Just as before, you can use nonce instead of PXE for confidential clients. PXE is recommended, but you may use nonce if you also observe some additional precautions. These additional precautions are essentially that you must ensure that the nonce is checked properly and from the correct ID token. That is, if you have an ID token, both at the token endpoint as well as in the authorization response, then you must also check the nonce in the first one. So that's something we stated very clearly again in this draft, because it might not be obvious to implementers. Then we had a couple of other important changes. Something we discussed in, I think it was the last call, regarding the security BCP somewhere earlier in the year. We discussed a new wording around the implicit grant. And this is also, I think this has been discussed very extensively. This wording is now what also can be found in the document. A smaller change, as you know, as you probably know, we say that you should use exact string matching for redirect URIs because it protects from a couple of attacks. And we now have one caveat to that, which we've taken from the native apps BCP. We say that if you use a localhost redirect URI, you may use variable port numbers because native applications just might need that. We also covered two new topics regarding attacks. First one is essentially just one paragraph. What happens if you have cross-site scripting? Of course, this can undermine your token replay protection if somebody can inject code into your application. And we also have a section on clickjacking attacks, which is essentially completely new. In the last call, we also discussed what we want to say regarding MTLS. MTLS is now the kind of suggested method for token replay protection, but it's not longer, as it used to be, the only recommended option. We have also gotten feedback that the discussions were a bit, let's say, lengthy. So we discussed several approaches to mitigate some attacks. Some of these discussions were not very helpful because they discussed things that might not be very practical. So we tightened the text around that. And we improved the examples, also feedback we got from the working group last call. And of course, we made several editorial improvements. So these are the changes in a nutshell that we made since the last working group last call. So what's there left to discuss? Actually, I think not too much. We have two things that I'd like to discuss today, and of course also on the mailing list afterwards. This one has already been on the mailing list. As you know, we say that because we now have PXE as a mandatory feature, you should also publish OAuth metadata to tell your clients that you actually support PXE. We say that you can have a deployment-specific way to communicate PXE support, but OAuth metadata is recommended. But this is only for the AS side of things. What we currently don't say is that clients should actually use this. So this came from a discussion with Guido and the other guys at the Stuttgart University. We found that it might be a good idea to actually recommend OAuth metadata to clients for their discovery process. We can reach several goals with that. First one is we can promote automation in the sense that you can now use features just based on this discovery process. So you might also be able to use advanced features like PAR or JAR just based on this discovery process. This also affects security features. Of course, PXE is a prime example, but it also reduces the chance for mistakes. As you might know, in the FAPI, in the current FAPI specification, there's a paragraph that says that one venue for attackers might be a misconfigured token endpoint. Of course, this is something that can happen if you configure the token endpoint manually, but it's less likely to happen if you have a metadata document that you can pull this information from. So I think it would be very useful if we would see broader adoption of OAuth metadata, and it actually improves security if we recommend each client to use OAuth metadata if available. Of course, it just makes OAuth also easier to deploy, but it also makes security features easier to deploy. You have essentially solved one part of your key exchange problem if you want to use signed or encrypted messages. And it might also promote the use or the concept of the OAuth issuer, which can also help to mitigate OAuth mix-up attacks. Speaking of which, regarding mix-up attacks, so this is the second topic I'd like to discuss today. The current recommendation, as you probably know, is that you should use, so you must mitigate mix-up mitigation, and one way to do that is to use separate redirect URIs per issuer. That means that if a client can work with multiple authorization servers, the client should have a different redirect URI registered at each of the authorization servers. This was a result of the discussion on how to solve the mix-up attack. And I think we settled on that because this solution is based on existing OAuth features. But it turns out that it's not always the best solution, I think. For example, and this is a problem that we actually have at yes.com, this solution is not suitable for schemes where you have a centralized client registration. So the client just registers once and can use many OAuth authorization servers or issuers, so to say. I think this is a pattern you often see in open banking schemes. This solution also, as you can tell from the text that we have in the BCP, needs a lot of explanation to developers. So what do they need to do? So why do they need to use a separate redirect URI per issuer? What is an issuer? Is a separate redirect URI per authorization server okay? Or is it not okay? What's the difference between the authorization server and issuer? What exactly to pull or to put into that URI and so on. And it's also easy to get wrong. And I think the best argument against this solution actually is it's very hard to automate in libraries, because the library might not know about your URI, how your URIs are built, what you put into these URIs, and so on. So I still think it's a valuable thing to have, but I think there are better solutions. And one such solution is something we also discussed very early on in this whole mix-up topic, is to put an ISS parameter into the authorization response that tells the client which issuer the authorization server thinks it belongs to and which was used in that authorization process. This ISS parameter is something that, again, we discussed very early on already in the process. So it's actually the solution that we have in the first paper where we described the mix-up attack. We already had the solution with the issuer parameter, and we already proved formally that it actually solves the mix-up attack. So it's a very good mechanism against mix-up attacks. Carsten Meyer zu Seelhausen, who is also on the call today, he created a new draft, which specifies exactly that, an ISS parameter for the authorization response. I think he also already posted on the mailing list today. The draft defines the ISS parameter and a respective metadata flag, of course. It's a very short draft. I think most of the things in the draft tell about how this source mix-up. Again, it's formally proven already. And I think if we had this ISS parameter, this would be easy to automate, or a defense that is very easy to automate in OAuth implementations, in libraries that evaluate that metadata flag. So I propose that we put this into the security BCP. So we could say that clients must prevent mix-up attacks either by using the per issuer redirect URIs or by using the ISS parameter, where we would then point to that new document.
This is Mike Jones. Can I reply to that?
Sure.
If you're using an ID token, you already have the issuer parameter or the issuer value, so you don't need the parameter. So just like we did with nonce, you should describe that if you have an ID token in your flow, then you already have the issuer and can use it.
That's a valid point, yes.
Thank you.
This is Aaron. Can I ask a question about this?
Sure.
Go ahead.
Seems like another way to solve the attack is for the client to maintain state itself, so it knows the request initiated. Is that a valid way to solve it as well?
Well, how would the client know where the code came from?
Same way it is storing the PXE code verifier.
Well, the client just gets an authorization response, and it just doesn't see where it comes from. So the client just gets it from the browser, and this is just a redirect to the client containing a code. And since, of course, the code is opaque, can't tell where if this code is coming from the attacker AS or the honest AS.
I guess my point is that it already has to store state. It already has to store the PXE code verifier to send that in with your authorization code. So it seems like it could also store where it expects the code to come from. And if the code is coming from an attacker, the attacker could just as well swap out the ISS parameter.
Yeah, exactly. So the client, when using this this mitigation, the client would need to do exactly that. So the client would need to know which ISS parameter it expects in response. And the nature of the mix-up attack is that the authorization response always comes from the honest AS, directly from the honest AS, and the attacker cannot intercept the authorization response from the honest AS. Because, of course, if the attacker could intercept that authorization response, then the attacker wouldn't need to do the mix-up attack in the first place. So if you do mix-up, you know that the authorization response comes from the honest AS. So it's not tampered with, and the ISS parameter is the original one.
Daniel, could you just walk through that as to how does it protect about a bad ISS sending it?
Sure. Okay. How would we pull off a mix-up attack? Let's say you're using OAuth metadata. So the whole thing starts with, as you know, in a mix-up attack, you have one client and at least two issuers. So one issuer is honest.com and one is attacker.com. These are the issuers, and the user would go to the client and say, I'd like to use attacker.com as an issuer. So, for example, by pressing a button, I don't know, authorize with attacker.com, I don't know. So the client starts the interaction with attacker.com, retrieves the metadata document, and in the metadata document, the attacker, acting under the issuer attacker.com, would say, my authorization endpoint is honest.com/auth, and my token endpoint is attacker.com/token. Okay, so the metadata document points one thing, the authorization endpoint, to the honest one, and the token endpoint to the attacker. Now what happens is, of course, the client sees that metadata document, evaluates the authorization server URL, and then sends the user to that authorization server, and that is honest.com/auth. So the user sees honest.com's authorization endpoint, logs in, authorizes the client for access, and then gets sent back to the client. So the client receives an authorization response, which comes from honest.com/auth, contains a code for honest.com, but the client, of course, still thinks that all these things are happening with the issuer attacker.com. And now the client will, of course, want to redeem that code for an access token. So the client goes to the token endpoint. And the token endpoint, of course, is attacker.com/token. So what happens is the client sends the code that it acquired from honest.com to the token endpoint attacker.com. And at this point, the attacker knows the code. And yeah, so essentially, it's game over at this point. Of course, you have then features like Pixie making this attack harder and other things. But still, to get defense in depth, you need to prevent in the first place that the code can reach the token endpoint of attacker.com. So if you had the ISS parameter in the authorization response, then of course, in the scenario that I just showed, the honest.com/auth authorization endpoint would put into the authorization response the issuer honest.com, because the honest.com authorization server knows that it's acting under the issuer honest.com. So the authorization response arrives at the client, and the client sees, okay, this response comes from honest.com, while I as a client am thinking I'm interacting with attacker.com. So the client would see the mismatch there, and then can stop the transaction. And the whole thing also works if you don't have metadata, but then you need to essentially you need to deployment specific way to say what is the issuer, so to say, in that case. which can be as easy as a fixed string that you know that Facebook always sends this string and Google always sends this string.
Thank you.
Makes sense. Thanks for describing that. Can you explain how Pixie does not solve this?
Well, Pixie kind of does. So with Pixie, the code would arrive at the wrong token endpoint, but of course the attacker wouldn't know which Pixie verifier to use for that code. Problem is that, first of all, we don't know if Pixie was used. Of course, if you follow all the recommendation, Pixie was used. But if you don't, then you still have the mix-up problem. Second is that there might have been a chance for the attacker to influence the authorization request in the first place. For example, by kind of proxying that through his own server. And that means that the attacker could know which code challenge was used. If that code challenge was clear text, then of course the attacker would just know the code verifier. Otherwise, the attacker might be able to just select their own code challenge in the authorization request. So the idea would be that in the metadata document, the attacker would not write authorization endpoint is honest.com, but instead the attacker would write authorization endpoint is attacker.com/proxy, and attacker.com/proxy would just change the authorization request.
I think I see that. Last question. If a client is only ever interacting with one authorization server, none of this is necessary. Is that correct? And if so, can that be explicitly stated?
Yes, that's correct. And yeah, I see whether we have that already in the text, or otherwise we'll need to put that there very explicitly, yes. Anything else?
Okay. Anybody has any other questions about previous slides? Okay. So Daniel, like, do you think you want to wait for this document to kind of progress, and then kind of see how that goes before we kind of continue to move this document along?
That's an excellent question. I think it's time that we publish the security BCP, and I think by putting the ISS parameter into a separate document, we've kind of decoupled those. That's at least what I hope. Of course, I know that it could be a problem to link to reference what is right now an individual draft. So I think it would be great if we would find a way to proceed with the security BCP more or less independent of the other document. I'm not exactly sure what we would need to do for that, but I guess that others could help me out there.
Yeah, individuals draft specifically, so it'll be a challenge. Roman, do you have any thoughts on if we can progress the document with an individual draft in a reference?
Sorry, but I don't understand the question. Could you say it again? If we can't progress the document, what? Sorry.
So that it seems that what Daniel is trying to do is is trying to describe an attack and refer to an individual draft, which is just there is lots of noise on the bridge. So if you are not speaking, can you please go mute? There's lots of noise. Well, somebody is doing something there. So So the point is, the question is there a way to progress a document through the ISG with a reference to an individual draft still?
Sure. I think a couple of things matter. It depends on the track we want to publish this particular document in. Ultimately what will happen is if you have a document that has a normative reference on another document that is not yet published, it'll sit in the RFC editor queue as a misref until they're deconflicted. And then depending on the track of that other document, if you have, for example, have a standards track document that you want to advance, but the reference is normative, and if it's informational, we'll just need to make sure that we appropriately broadcast the down ref during the last call.
This is Hannes here. I was wondering, I was listening to Mike's comment early on. He was saying that the ID token, so if you use the ID token, you essentially have that parameter in there already. Is that also something that we need to take into account in this whole debate or write-up?
I would ask that, this is Mike again, I would ask that we update the document with the resolutions to my comments and the resolutions to Aaron's comments before we would do another last call.
Yes, that would be the plan anyway.
Right.
Okay, thank you.
Yeah, the plan wasn't kind of to go last call right now.
But still, to the other point, Rifat and Roman, if it depends on how we reference that solution specifically in the document. If it's referenced as informative, then obviously it wouldn't be blocked. But otherwise, clearly, as Roman explained, it would be sort of stalled till this other document is completed.
Yeah.
I mean, this could be a chance, right? So it looks like we have kind of two ways to transport the ISS, not the space station. In the authorization response, one is the ID token, one is a separate parameter. So this could be, in my opinion, an informative reference in the beginning, at least.
I mean, as long as the solution is described in the BCP text, I could also see the further details on the attack as being informational, because they would not be required to be known to implement the solution. And as long as we keep to that line, I think we can have that arrangement.
But it would actually be the solution, not the attack. But we would, I mean, in the security BCP, we could say, if you have a way of sending the issuer from the authorization endpoint to the client, then that also solves the problem. And one way could be the ID token and informative reference, this other draft.
Yeah, that could, I think that could then make it a normative, informative reference, and that would be good.
Why would that be informative? Like if the ID token is not there, then the right way to do it is through this parameter. So it's not going to be informative, right?
Yeah, but at least, yeah.
No, it sounds like the security BCP would be saying you need to solve this attack, and there are several options to do that. You could also make up your own solution. However, it would then point people toward the intended to be standardized version of that, which is this ISS parameter.
Yep.
Thorsten speaking. You could see it that way. The security BCP states the parameter could be a solution, and then UDraft picks up on that point and makes it an interpretable standard.
Okay. Okay, I guess we need to think about a way kind of to progress this. Okay, so then let's.
Would it make sense just to go ahead and define the parameter and the associated metadata in the security BCP and avoid the logistics? I know that folks were trying to avoid that, but
but then the document wouldn't be a BCP anymore. It would be a standard track, right? Because you're introducing new functionality, right?
Well, I'm not sure. It's not clear to me that that's the case, just including one additional parameter and how it's used. I guess I would defer to.
This is Roman speaking. It would feel a little odd to me to be registering new parameters in the BCP document. It
Right.
seems like that document should be pointing to all the other things that have the guidance and having the normative language around using those protocol features or not, or whatever is the appropriate caution.
Yeah.
That's fair. It just seemed like potentially it's less awkward than all these various attempts to downplay a downref or backref to an individual draft document. Although I presume that this discussion sort of presupposes the adoption of the other document and attempts to progress it quickly.
I mean, this is something we could also just try to progress with the security BCP and see how much need for discussion there is. With the other document, it is a relatively short document and very concise. So maybe this progress is quick enough. Otherwise, we could still think about how to reference that properly.
Okay. So then I guess for now you still have some work to do, Daniel. Let's update this document based on the feedback you got today, and see if we can have some discussion about this new draft, and if we can make a progress on that in parallel, and see how far we can go with this.
Exactly. Sounds good.
Okay. Any other questions for Daniel?
Yes, this is Danny speaking.
Go ahead. Go ahead. Do you have a question?
Okay. It's a topic that I've already raised on the version 15. Currently, the section 3 states the updated OAUTH2 attacker model is supposed to have been updated to account the potentially involving multiple parties. However, it still misses to address the case of dynamic relationship between clients, which includes scenario of collaborative clients. Now, on November last year, Daniel wrote, "I have the feeling that this attack, which means a collaborative attack, aims at breaking a security property that OAuth does not claim to fulfill and that nobody expects OAuth to fulfill." Well, I believe that the attack should be mentioned, and it has two flavors. Let us suppose that you have a token that contains only a verification of the age, saying that the person is more than 21. Well, this kind of token should never be accepted by a server, because in case of a collaboration between clients, you cannot know who has forged or has provided the token to the other client. However, if the token includes the subject identifier, you know that who is the person doing the impersonation, and now you feel in the problem of impersonation. And it means that the way to counter the attack is basically to always include a subject identifier that allows the service or the server to basically authenticate the owner of the token. So I believe that this should be mentioned in the document.
Okay, Daniel, any thoughts on that?
Yeah, I think we've discussed this attack a number of times, also in different working groups. And it seems that so I still stand by what Dennis quoted. that this seems to break something that nobody really expect OAuth to provide, which is also kind of supported by the, I don't know, my general impression that this discussion of the attack has not brought us really to the conclusion that this is an interesting attack, so to say. Just one thing that I also pointed out before, this attack is covered by the attacker model. Collaborative clients is something that can happen. The thing is, it is not covered by the kind of security goals that people expect OAuth to fulfill. And yeah, so I don't really think that this is something we should cover in the security BCP.
Well, collaborative is not a word that exists in the current BCP. So collaborative clients do not exist as well. As you mentioned, this kind of attack can happen. And we should say what should be done in case that attack happens. And mention that there is a way to counter that attack. And this should be mentioned.
Again, collaborative clients are covered by the attacker model because clients can, of course, send messages to each other. This is also something that we covered in the formal analysis, where this attacker model kind of is derived from, where clients can collaborate. So they can collaborate to reach a common goal.
Could you point me to the text where you have the word collaborative in this document?
No, this word is not in the document. We just say that clients can send messages to each other and they can act together. So
it's much more than that. It's not sending messages. It's making cryptographic computation for the benefit of the other client. And this is never mentioned in the document.
Again, I recommend you to read the original formal analysis, which covers explicitly this thing, this attack.
No, there is no section dealing with that problem in the BCP. That's a key point. And there should be one.
This is Hannes here. Yeah, I wonder. I see two aspects here. One is the question of like how well is this aspect covered in the document itself rather than in reference documents, and can we do a better job in pointing these things out on what's covered and what's not covered. The other aspect is I'm sort of talking about solution aspects and having an agreement on a group, whether this is something they worry about in OAuth. And I know that in like what people care about in a group in terms of attacks changes from time to time, but maybe that's something to think about, and I can kick off an email to discuss this aspect as you are Daniel, as you are updating the document for the other issue we discussed before. How does that sound?
Yeah, I think we should also, in the interest of publishing the security BCP, consider this maybe for a future update.
Okay.
Okay. Any other questions, comments? Okay, then I think we're done for today, and we'll see you next week, guys. We still have another interim next week, next Monday, same time. Okay, thank you all.
Thank you.
Thanks for the feedback. I'll distribute the meeting minutes as soon as possible.
Awesome. Thank you.